once again, good morning, good afternoon, good evening, whatever you are listening to the video. So, or you are watching this video. Today we'll be talking about separable variable, and we'll also look at homogeneous equation, how to use homogeneous equation to solve differential equation. And from there, we'll move on to other fantastic application or some of the examples that we have there. So it will help us also to look at how to solve some of the problems, especially in our books and other areas we intend to apply it. So I will be sharing the screen now. Okay, thank you for listening. So we discussed about population, about example, but today, like I said, we're talking about separable variable. So they are there in your, if you check your textbook, let's go to the course material. They are here. I want you to go and read the notes by yourself. So during the course of this, we'll be talking about this, but we've done this one before now. Integrating factor is still the same integrating factors. We've done how to apply them. So that is one of the we need to look into. Are you getting it now? So can someone read for us from the screen? If you can see, introduction. Can you read?
In Unit 1, we introduced the basic concept of definitions involved in the study of differential equations. We discussed various types of solutions of an ordinary differential equations. We also stated the conditions for the existence and uniqueness of the solutions of the first order differential equation. However, we do not seem to have paid any attention to the methods of finding these solutions. Accordingly, in this unit, we shall confine our attention to the same. In general, it may not be feasible to solve even the apparently simple equation dy dx minus that is equals to a function in xy, or a function gs of y dy dx equals 0. Well, I didn't say that correctly, but I think everybody think they can understand what was there. Where f and g are arbitrary functions, this is because no symmetric procedure exists for obtaining its solution. For obtaining its solution, I think I miss okay.
Okay.
Arbitrary forms of f and g.
So what else do we need to do now? Let's look at another person should read for us separation of variable.
You know, separation of variables.
You know the.
Yes, go ahead.
Separation of variables. You know that the problem of finding the tangent to a given curve at a point was solved by Leibniz. The search for the solution to the inverse problem of tangents, that is, given the equation of the tangent to a curve at any point, to find the equation of the curve, led Leibniz to many important developments. A particular mention may be made of the method of separation of variables, which was discovered by Leibniz in 1691, by providing that a differential equation was of the form of dy dx equal to x of s and y of y is iterable quadratures. However, it is John Bernoulli in 1694 who is credited with the introduction of the terminology and the process of separation of variables. In short, it is a method for solving a class of differential equations that arises quite frequently and is defined as follows. Note, the process of finding the areas of plane regions, if called quadrature, is called quadrature. Quadrature,
Now,
Definition.
it's okay like that.
Okay.
So what we are saying here is, I'm just trying to lay a foundation for you. But the main thing is, how do we solve this problem? That is our concern. But you need to know the background. Please, I want to employ you, take your time also and read those words. They mean so much, and it will give you better understanding of what we are actually saying. So let's try as much as possible to look into that while we continue. So let's look at the example. Okay, when you have the y, okay, let me just say, when you have y prime is equals to p of x, q of y, y prime, p of x, q of y. It's the steps to take is the same thing as, first thing, when you have equation like this, you have to turn it to the y, the x, or the y dt, depends on the other function, other things that you are given. So it will be in this form. Please, everybody mute yourself. Once you are not talking, mute yourself. It will help us. Thank you. So what are the things you need to do? Separate x term and y term. Integrate both sides. The y is like this, that is, step one is one of the things you need to do is, in step one, is just to try as much as possible. Yeah, somebody is raising up their hand. Thompson. Any problem?
No, sir. It's a mistake. Yes, sir.
Just lower your hands. Others, please mute yourself. Okay. So what we need to do now is, let's look at Roman figure 1. Roman figure 1 says, separate. We are to separate S term and Y term. That's your first assignment. Number 2, second assignment we need to do when you are given this question is integrate both sides. Integrate both sides, that is y term by dy, which is the same thing as s term so y term, s term. The s and everything plus c, that's all. So once you can get that, you finish separation variable. So we can go ahead and look at example. Now, the first example says, number one example says, y prime plus 2xy equals to x. Y prime plus 2xy. Remember, all you need to do is change this one to the y, the x equals to, okay, the y, the x, let me just write it, finish first, plus 2xy equals to x. Don't forget our target is to separate x and y first. So we move on by saying the y, the x equals to x. Take this one to the other side, minus 2xy. Something is common to both sides here. I can say the y dx is equals to x is common, x 1 minus 2y. Can you see it now? So in this case now, we need to divide both sides, or we need to multiply both sides rather, multiply both sides by the x. So I will have the x multiplied by the y, the x here. Okay, let me just use this bracket for this. Equals to s into 1 minus 2y ds. So that means the s cancel the s here. So I now have the y equals to s into 1 minus 2y dx. So who can tell us what to do again? Remember, x must go to x, y must go to y.
We divide both sides by 1 minus 2y.
Yes, divide both sides. Let's write it. Divide both sides by 1 minus 2y. So if you have to divide both sides by 1 minus 2y, I have the y over 1 minus 2y equals s into 1 minus 2y dx, everything divided by 1 minus 2y. So this one will go with this. Are we together now? So here we have 1 over 1 minus 2y dy equals x dx. So now, the second step says, you remember all the steps I have mentioned here. The first step, separates x term and y term. We've done that. The next thing is to do what? To integrate both sides with respect to the y term and the s term plus c. So we are going to do that now. So integrate both sides. Integrate both sides. So for us to integrate both sides, certain things are involved. So when you said integrate both sides, will be 1 all over 1 minus 2y dy is equals to integral of x dx. This is where we will test your integration ability. Whether you just cram and just pick answer during your integration, during your calculus, 1 calculus 2, this is where they will test it. So I don't want to assume that you know, or should I assume you will know it and just jump it?
No, please, we don't know it too.
Really? Okay,
Please.
let's look at, okay, who can tell us? What do you think?
Hello, sir.
Yes.
We don't know it. Please explain.
Which one should I explain? Ruka, Abi Olanike, yes. Which one you don't know?
When you say you want to assume that we know it, when you say you
You are
want to
scared.
assume, so yes, sir.
Okay, let's look at this. For us to integrate this side alone,
Can I try, sir?
for us to integrate this side alone, let me pick another pen. We said, let's u, okay, don't forget we are integrating this side, dy. We are still coming to this one. Let's call this one A. Let's call this one B. Are you getting it now? Or let's say A1 and A2. For A1, this is A1 now. For A1, we have 1 over, with respect to Y. How do we integrate something like this? All we need to do is just to say, let U equals to 1 minus 2Y. The U, the S, you remember, the U, the Y will be what? Who can differentiate this? What is the answer?
-2.
-2. But remember, from this integration, we only have the Y. So if I say let U equals to this, that means the integral here will be integral 1 over U. What is going to be my dy? That is the question, in form of U. So I'm going to make the y subject of formula. So I will have the U equals to -2 dy. Cross multiply. When you cross multiply here, what do you have? The U equals to -2 dy. And my target is y, because I want to substitute y here in form of U. So what I do is just to go ahead and divide both sides by -2. So this one will go with this. So my dy will be equals to -1/2 du. So from this integration now, I can substitute my dy there. I will just divide it so that you can see what I'm doing now. So it will now be in integral of 1/u in brackets -1/2 du. So I can take this one out. -1/2 is a constant. I can take it out. 1/u du. You and I know when you integrate 1/u, what do you have? Anybody?
Lin U.
Lin U, thank you. So you have -1/2. Then it's going to be in ln absolute value U plus C. Are you getting it? But that's not we don't need all this plus C for now because we are still working. Remember, we only solve our A. This is our A1. Going back to the equation up, we are going back to this one. Let me call this equation, equation 1. We substitute the solution back into equation 1 to that part. So let's look at it together now. So we have it to be -1/2 ln absolute value of U. Are you getting it? Equals to, I can now integrate the other side. integral of x dx. When you integrate the x dx is what?
X squared over 2.
X squared over 2.
X squared over 2. So we have minus 1 all over 2. What is our u?
1 minus 2y.
Integrate x. You have x squared over 2, everything plus c. So now, what do we need to do at this point? Multiply through by 2. If you multiply through by negative 2, multiply through by negative 2. So when you multiply through by negative 2, you have negative 2 multiplied by negative 1 all over 2 ln 1 minus 2y equals to negative 2 x squared over 2 plus c. So this one will cancel this. So we have what we have ln 1 minus 2y equals to negative x squared plus c. So you discover that I didn't bother myself to multiply this one by 2 because I know anything multiplied by constant will still give you the constant. It's still c. So in this case now, we need to have y. We are solving for y. So let's look at it. Take exponential of both sides. You have exponential of ln 1 minus 2y equals exponential minus x squared plus c. So at the end of the day, I have here the positive is 1 minus 2y equals exponential minus x squared. You know that plus c, you remember that when you have a raised to power x plus multiplied by a raised to power y is the same thing as a raised to power s plus y. So that is what we have here. So it simply means this is dot exponential c. So which is meaning that it's still the same c we are talking about. Exponential c is c. So while we have y minus 2y equals to c exponential minus squared. So to make y subject of formula here, we have what we call minus 2y equals to c exponential minus s squared minus 1. Divide both sides by minus 2. So we have, at the end of the day, we have y equals to minus c exponential minus s squared, everything minus 1 divided by 2. So this is your answer. Any question?
Hello, sir. I have a question.
Go ahead.
When I was looking at it, I was
I
thinking,
can't hear you very well. It's better you speak louder, please.
Can you hear me now, sir?
Still faint? Go ahead.
I was thinking maybe the answer could also be 1 minus c exponential minus s squared, everything over 2.
You are thinking what?
I'm thinking we can have the answer also as a 1 minus c exponential minus s squared, everything over 2.
Hello, sir. Can I ask something, sir? When you were dividing by minus 2, I think the minus 2 should be applicable to both the 2 on the right-hand side. It should be minus CE, and then that minus originally should be plus. The minus should be changed to plus.
Is it okay like this?
Yes, sir. That's what I meant, yes.
Are you getting it now? The other guy that was talking, I can't hear what he's saying. I'm sorry. Okay. Can you speak again?
Hello?
Yeah, I can hear you now. Thank you.
Okay, I said when you that will be 1 minus c exponential minus s square everything over 2.
1 minus c
C
exponential.
exponential minus s square everything over 2 instead of minus c minus 1.
Yes, you are right. It's possible because that was what Ibrahim is saying. It's still the same. If you want to conclude this way, y open the bracket with minus c exponential minus s squared plus 1, everything over 2, which is the same thing as 1 minus c exponential minus s squared all over 2. Is it okay by that now? Are we okay now?
Yes, sir.
Okay, let's continue. So, when it comes to variable separable, you don't have too much to, we don't have much to waste time on that. Anytime you see any question of variable separable, follow the same method, follow the way of solving it, and it will help you. But now let's look at the homogeneous. I don't want to, like I told you, I don't want to stay too much on that particular one. For homogeneous, because we will need separable variable in homogeneous, we will be applying it along the line. You will be seeing the way we are applying it before the time runs out. Okay, let's look at the homogeneous. There is one in our question, in our textbook, which I will still explain later, but let's look at this, homogeneous. Homogeneous method. For homogeneous method is it's a kind of method that demands our attention. For example, when you have f k s comma ky equals f of s comma y, and in most cases, okay, don't let me just go to this one because I want to prove something. Don't let me just start with this. Let's just say let v. We kind of we normally use substitution method in solving this. Let v equals to y over x. Let v equals to y over x. Then what is y in this case? Y is equals to vx. Now, the question is, what is the y? Let's say the y alone. The y alone will be what? We are going to use product rule. Hold one constant, differentiate one. Hold another one constant, differentiate another one. That's the way we normally use it. But it depends on what you are solving. It depends how you want to solve it. It depends on the problem. The problem will determine which one are you going to solve first and how am I going to solve it. Please, in homogeneous, it's not one-way traffic. It depends on what you are solving, like I told you. Now, I have the y. What is the y now? It's going to be, I'll solve the v, I said the v in bracket s as a constant, plus I I will differentiate the v. I will differentiate v. I will hold v constant, differentiate x using product rule. So which means s dv plus v dx. That is my dy. Then if I want to now calculate the y dx, I can now say, okay, the y dx will be let's divide the both side by dx. It's going to be this dx, this is dx. So at the end of the day, my dy dx will now be x dv dx plus v. So we use this often in it. Some other people also use this, the first one. As a matter of fact, all these ones that I listed here, they are all important for us to use. So there's no one that you cannot use when it comes to homogeneous equation. Now, how do we now get homogeneous out of the old problems we have? Let's look at the examples. Example 1, or example 2 now. We've done one the other time. We have 2x dy equals to s plus y dx. So the first thing is we first of all need to separate them. Divide. When you separate them, you will be able to now, it will help you to be able to solve some of the problem. How do we separate this one? Anybody? Look at the board. I want you to talk, please.
Yeah, we take the dx to the left side and the dy. We take the s to the left side and 2x to the right side.
Okay. Who else again?
So what do you intend to separate, sir? The x and the y terms?
Yes,
you mean the
you have to.
Okay, the issue that at the end of the day, I think it's going to be complicated. You try to separate them.
Good. Now, don't separate yet. You can only separate after you substitute your y. You can only separate when you substitute, when you know your y. Solution says, let's look at this. Let y equals to vx. Meaning anywhere I see y, I'll substitute vx. This equation is straightforward. Then I know dy will be equals to, like I told you the other time, x. I have the y already. You can also differentiate it by yourself. S dv plus v dx. So which implies that I have 2s. What is my dy? Substitute it here. S dv plus v dx equals to, I have my x. What is my v? What is my y? Plus vx dx. You can see everything is in form of vx now, not x dy. So let's move on. In this case now, you open the brackets, or you still leave the bracket open, x into s dv plus v dx equals to, something is common here. S is common, 1 plus v is here, dx. You agree with me that I can say s cancel s here? So I have 2 into, I can now open the bracket, 2x dv plus 2v dx equals to 1 plus v dx. Any question? So you can open the bracket of VDX also. Let me just open it once and for all so that we can be on the same page. X multiplied by 1, the X, plus V, the X. You discover that some things also we common, we go, we minus, then you can do that. So what do we do here? Anybody?
We collect lactants. We bring the
So
VDX.
you have 2S dV, right? Plus 2V dS minus V dx equals the S. So I have here, which means by 2S dV, this minus this. You remember one has 2V, the other one has single V. So it's the same thing as what? Plus V dx equals the S. Any question? So at this point now, we can begin to look at it. How do we separate them? So this is where the variable separable now useful equals to the x minus v dx. So I have here, I can easily say 2x dv equals to 1 minus v ds. So we can divide both sides by what? Who can tell me?
At this point, 1 minus v and 2x also.
2x.
So how do we know? Let me explain to others. It is simple. What we are going to do is simple. Look at I know that, okay, let me do it one after the other so that other can learn from it. I need here, the V is here, the S is here. I want X to become here, and I want V to be here. So I can now use this and this together by saying 2S should be divided, and 1 minus V also should come. Then here, 2S again, and 1 minus V. So 2S here will go with 2S here. 1 minus V will leave this place. It will remain X, it will remain V, the other side. So which implies that I have 1 over 1 minus V dV equals 1 over what? 1 over 2S ds. So at this junction, all you need to do is just to integrate both sides. It's for you to integrate the both sides. So how do we integrate the both sides, please? Integral of 1 all over 1 minus V dV equals 1 all over 2 integral of 1 all over x dx. Any question? If you use the same method that I did the other time, let's V 1 minus V equals to U. When you differentiate it, so you are going to get, when you differentiate it, you are going to have what? And substitute it and integrate, you're going to have negative ln 1 minus V, which is equals to 1 all over 2 ln x plus c. Any question? Any question? No question. Okay. According to the law of logarithm, anytime you have, remember when you have n log s, is the same thing as log s raised to power n. So we're applying the same law here by saying you have ln 1 minus v raised to power minus 1 because of this negative. It's the same thing as ln s raised to power half plus ln c rather. So it's still the same ln. So when you put the ln c here, it's the same thing. It doesn't have anything here, it doesn't have anything to do with this. Now let's move on. In this way, I can rewrite this one by saying ln 1 all over 1 minus v. You agree with me now? Because when you have s raised to the power minus 1, same thing as 1 all over x. So take note of that. So, which is same thing as ln square root of x plus ln c. So, at this point, when you have ln a plus ln b, it's the same thing as ln ab. So we're using it here by saying ln 1 over 1 minus v is equals to ln c square root of x, root x. So then the ln will go with the ln. So we are left with 1 all over 1 minus v equals to c square root of x. Recall that v is the same thing as, recall that y is equals to vx. Then what is v? Our v will be what? Y over x. Thank you. So substitute y over x. What do you have? You have 1 all over. Because your answer must be in y format, not in c, and not in v. So you substitute it here, 1 minus y over x is equals to c square root of x. So when you rationalize this one, at the end of the day, you are going to have x over s minus y equals to c square root of x. But we still need our y, don't forget, is your target. So what you need to do at this point is just to try as much as possible to multiply both sides by s minus y. So s over s minus y equals c square root of x into s minus y. So this one will cancel this. So I have x equals to c square root of s in bracket of s minus y here. But we still need to eliminate c squared, square root of x. That square root, how do we eliminate x? That means we need to square the both sides, square the both side. So I'm going to take the square of both sides. I'm not saying square root of both sides because I need to eliminate this square. The only thing that can eliminate this square is to square the both sides. So I have s squared equals c of s minus y all squared. So for me, I will need s squared equals to c squared, and I have square root here of s all squared, and I have s minus y all squared. So which means this cancel this. So I have here s squared equals to c squared s in bracket s minus y all squared. You need to take your time like this where you are solving this problem. That's the beauty of it. Let's divide both sides by s. S is here. This one cancel this. This is remain only x. So it makes my life simple now. I have squared in all sides. In the other side, s is equals to c squared into s minus y squared. So at the end of the day, don't forget our c is still constant. C squared is still c. So we have s equals to c in brackets s minus y all squared. So our final answer will be the modulus of x equals to c in bracket of s minus y all squared. That is your homogeneous. Who is that? Just raise up your hand if you have to say anything so that. So this is our homogeneous equation. Any question? Yes, Charles.
So I thought we were solving for y before.
Remember, this is homogeneous. That was separable variable. It depends on the question. The question will determine how to go about it. But in most cases, when it comes to homogeneous, we in most cases we look for, you can solve for x, you can also look, it depends, like I put it, because if you are going for y now, that means you need to find the difference of two square. You need to also break it down again before you can move forward. I hope you get my analysis in that case. So you can also go further. If you want us to also solve that for the y, you can also do that. Any question? Have I answered your question there?
Yes, sir. Yes, sir. You did.
Any question before we look into another thing? But for us to solve for y in this case, how do you think we can do it? Charles or anybody? What do we do?
I think the question.
Eh? What do we do?
To make it faster, I think to make it faster, we wouldn't need to expand this x minus y. We just take square root of both sides.
Square root of both sides, yes.
Yeah.
Okay, let's look at it together in order to make it work for every one of us. Let's make it together. So when you take the square root of both sides, when you take the square root of both sides, So we are going to have square root of x equals to square root of s, c. Then this will go, we have x minus y, right? So at the end of the day, when you open the brackets, c is still c. Do you agree with me?
Yeah, yes, sir.
Okay, we have square root of s minus equals to c into s minus y. So do we need to divide both sides, or do we need to open the bracket with c?
We'll divide both side by c.
Divide both sides by c. When you divide both sides by c, in order to eliminate those c so that you can easily open your bracket, so you have it to be square root of x over c equals to s minus y. So what happened to x minus y from here? Anybody?
Y becomes x minus root x over c.
So y will equals to x minus root s over c. Any question? Any question, please?
I think you can see written further down as x minus c root x, since c is a constant.
You can just do what? Y equals to s.
You can see minus c root x.
Minus c root s. How?
And since c is a constant.
Yes, you are right. That is 1 over c is still c.
Yes, sir.
Okay. So please, let's take notes. Now, let's quickly look at another example. That is more format. In case you are doing another one that is more interesting also in that way. Always know that you are to substitute. Yes, Charles?
As actually, that time when you wanted to start the solution, I was trying to say something, but you didn't understand what I was trying to say.
Okay.
I was envisaging a more faster method. Since we already know that our dy dx should be v plus x dv dx. So I was thinking we should just work on the right hand side, then equate it to v plus x dv dx.
So if you are doing the paper one, are you going to do it that way?
No, haven't separated dy dx to the left hand side, shift every other thing to the right. That's what I mean.
Anyway, probably if you do it in your sheet of paper and scan it to me, I will understand what you're saying better.
All right.
Okay, now let's look at this one. Let's look at this one. Let's say number 4 or number 3. I can't remember. So we have the y is what?
Example 3.
Example 3. The x equals to s squared plus y squared over sy. Charles, are you raising up your hands?
No, it's the one I raised before.
Okay, let's continue. So when you are given this question, how do you solve this one? Anybody? What comes to your mind?
Make y equal to vx. Then you differentiate.
Really?
Yes, sir.
you need to first of all look how to run away from square. Because your S in this case is not square. Next thing, you said I should preview everything. Oh, this course is not supposed to be a pen on paper because it's not e-exam. It's not supposed to be pen on paper course and not e-exam. Yes, this course is supposed to be a paper on pen. You don't understand? Not e-exam. Okay. It's because
to be a pen on paper.
Oh, you want it to be pen on paper?
So yes, that's what I was saying, because with what you are doing here, any little mistake will not arrive at the correct answer.
I understand your point. But okay, what do we do? You can anyway, because of the, I think it's because of the population of people that are offering the course. Maybe that's why they make it E. That is why you yourself in exam, once you get, I think I shared last time some of the past questions. You guys have past questions. You yourself take your time. If you are going to do 10 topics, 10 questions, make sure you know what you are doing. Probably somebody sitting beside you is doing statistics and you think you need to rush and submit your own. You know your own level is different from their own level. Don't join them. Take your time and practice very well so that you don't miss it. Let's solve this one. We'll talk on that later. Solution. Divide x, divide through by, divide all term by, divide all term by x squared. Just to make your journey simple, the y, the x is here equals to x squared divided by s squared plus y squared divided by s squared divided by xy over s squared. So at the end of the day, I will have here 1 plus y over x all squared divided by y over s. So I have the dy to be like this. That means I have my dy ds is equals to 1 plus y over s over 2 divided by y over x. So in this case now, let's y equals to vx. Then I can say my v is equals to y over x. So it made my journey simple. See, this particular question, this particular topic, there is no simple, there is no nobody will tell you this is the only way you can do it. You can do it in many ways. Are you getting it now? You can do it in many ways. That like the y, the x will equals to 1 plus v squared over v. You can see now. 1 plus v squared over v. Please, next thing, look at it the way we are doing it step by step now. Now, remember, who can tell me what do I need again?
So this is actually the method I was talking about before.
But the question is different. You can see the structure of this question. Are you getting it? Compare with the one you are talking about. The one you are talking about is a quite different question. You can see. Although I agree with you, we can divide both sides by, we can just divide both sides by what? In your own case. Look at this way.
We divide both sides by 2x dx.
2x dx. You are right. It's possible. 2s the s is possible. But we can easily make everything will just be Vx, Vs, Vx. I agree with you, because if you divide both sides by 2s Vs, where our y would be just be Vx, and the y the s, we just substitute the y the x automatically. So you can see, that was why I was telling you that we have different way of solving it. Now, we need to, please, for those of us that are not sound in calculus, you still need to review it. Now, I need the y dx to be in form of v. That is what I need now. So since I know that my y is equals to vx, what is the y ds? I've done that initially, but let's do it again. The y ds will be differentiate old s constant. Are you getting it? Differentiate v. I will have dv ds. That's all. Old s constant, differentiate v. Remember, everything is with respect to x in this case. So now I will now plus. Who remember this method? Product. What is the, how do you write product? dy ds equals to what?
U dv plus
U dv
v du.
U dv what?
Dx.
And plus v
Yes.
du
D,
s. So that is what I'm using. What I did here is I just hold u constant. What represents u here? We have x. I hold x constant and differentiate this. I will now hold v constant. I will now differentiate the x. You and I know that the x is over the x. So at the end of the day, I'm going to have the y, the s to be equals to s dv dx plus v. Because when this one will cancel each other, will be 1. 1 multiplied by v is v. So let me call this equation 1. This is equation 1. Then I'll substitute everything into equation 1. Equation 1 becomes all this will go to equation 1. Don't forget. So it will now be s dv ds plus v equals to what? Substitute. You have it 1 minus, is it 1 minus 1 plus v squared over v. Any question? Who is not clear to? So I can now divide both sides, divide this side again. I can say s dv ds plus v is equals to 1 all over v plus v squared over v.
Hello, sir.
This one will cancel this, right? So I have s dv ds plus v equals to 1 all over v plus v. You agree with me that if this one cross to this side, it will cancel, or if this one cross to this side, it will cancel this. So this one go with this. So what do we have now? We are left with, yes, Pascal. You can unmute yourself and talk. Pascal.
Okay, so I have a question.
Go ahead.
That from the product rule we stated earlier, where we said that v du ds. I don't know if you can take it back a little, so that's what I'm talking about.
Which one?
before we get to this, yes, that the y ds is equals to u dv ds plus v du ds. Then when I say that the y ds now will not be x dv dx plus v ds dx. I don't know how do we come about that d v dx dx.
Okay, you mean this? Let me use another pen.
V dx
Are you talking
dx.
about this side?
Yes, I'm talking about where we have this x dv dx plus v dx dx. Where you have to cancel that x, and we're left
let's
with
do
v
it
ds
one
dx.
after the other. We are using this. This is the quest. This is what we have. This is y equals to v over x. Now we now said let's differentiate v. Let's differentiate y, the entire y, which is this. And we know that the v, we know v is a function of x. So it's not a constant. Are you getting it? Yes. So you have to treat them one after the other. It's like you have s exponential s. If you have s exponential s in a product rule, you hold one as u, you hold one as a v, right?
Yes.
Now, the same way you undo this, the same way you will do this.
Okay.
Now, when you want to differentiate this one in the product rule, let's say you have u is here, let's say v is here. Now, look, I'm using this method now. If I want to differentiate this u, I will have the u, the s, right? Which is equal to, when you differentiate x, what do you have? 1. Am I communicating?
Okay.
When you differentiate the v, the s now, what do you have? Exponential s. Are you following?
Yes.
It's going to be exponential s, right? Now, substitute the u, the s, and the v, the s inside this formula. So if you want to substitute, what is our u? S. What is our dv, the s? Es.
E to x.
Plus, what is our v? Es. What's our du, the s? 1. So you write it out. Now, the same way that I explained now happened to this one. What is our u? What is our, let's say u is this, let's say v is this. Are you following? Now, u is this, v is this. Differentiate u, v, a different, that means at this point, I'm holding u constant, which is my v. I can rewrite this as v. I put my u is v now. I'm holding it constant. And I differentiate. Let me just do it separate here. Here. I'm holding u. Let me first of all differentiate. Okay, if I'm holding u constant, I have v. Differentiate the x with respect to the x. Right? If I'm now holding v constant, s, differentiate the u with respect to x. With respect to x. Since it's v, I will just put it dv. I don't need to put any value again. I'll just put it dv over the s. Since it's not valuable, we don't have value, it's just dv. It's just v. It will now be dv over the s. So the s ds, cancel it, is 1. That is why you see this one, we write this one at the end of the day. Have I explained it myself now?
Okay. Oh, yes, sir.
Are you okay with that?
Yeah, I'm okay.
Okay. Who else again before we move forward? Okay, let's move on. Nelson, are you okay with this now? Unfortunately, I can't hear you. Okay, let's continue. So what do we do at this point? We need to separate the variable. How do we separate the variable? in this case? Who can tell us? Separate.
Yeah.
Yes.
We multiply by v and divide by x.
We do what?
Multiply by v over x.
Multiply by v over s. Okay. Multiply by v over s, right?
Yes, yes, yes.
No.
Yes, it's v over x.
What about the s? What happened to the s?
Maybe we should multiply through by the s first.
Okay, we multiply by v dx over x.
V ds?
V dx over x, yeah.
Aha. Okay, but let's do it one after the other because some people don't understand what we are doing. Let's multiply through with v first. So we have x, v, dv, ds equals to v over v. Are you getting it now? So it equals to v. Let me just put it this way so that people will understand what we are doing. It's only few people can relate what we are doing. Multiply by v. So all of us, we agree we multiply by v. Then we multiply again by the s. So we have the s in brackets, sv dv ds equals to 1 over v in bracket v ds. Right? So this cancels this. Here we have ordinary ds. This one will also go with this. So we have sv dv equals to ds. So at this point now, we need to divide both sides by the x, by s. So we divide both sides by x. So the x here will go with this. So we have v dv equals to 1 all over s ds. Any question? Then we move on by integrating both sides. We have v dv equals to integral of 1 all over s ds. So how do we integrate this one? When you get dv, we have v squared over 2 equals to ln s plus c. So all we need to do at this point is, this is implicit enough, we can just say 1 all over 2v squared is equals to ln s plus c. Multiply 2 by 2, you have v squared equals to 2 ln s plus c. So at the end of the day, I need to continue. Remember, to make life simple for me, I will take the square root of both sides. I will have v equals to the square root of 2 ln s plus c. So what is our v?
Y over x.
Substitute your v here, equals to square root of 2 ln s plus c. Then we can now multiply through by x. So at this point, remember it's plus or minus since we are using the square root. So at this point, when you multiply through by s, you have plus or minus s square root of 2 ln s plus c. Any question? Any question? Let me stop sharing. I can see everybody silent. It is well. I know it's not easy. Philip, are you there?
Yes, sir.
Are you sure are you gaining something?
Really, sir. Yes.
Okay.
Yes.
Forget about your time. Your time will not be too much. Oh. Just make sure
we'll do our best.
Do your best. That's just an advice. Do your best. Don't worry, by next semester, you start enjoying the paper one.
Okay, sir.
You understand? Olayemi,
Yes, sir.
Olanike, your comment is what? I hope your head is not hot now.
We're fine, sir.
You said what? You said, please, I don't understand what you are trying to say, please. Okay, let's look at this. Some people are still chatting. The problem is now is, okay, the many times you are not reply, you are without doing anything. Okay. Okay, you want to say something? Y prime is equals to 2s exponential minus y over x plus y divided by x. So when you have something like this, what you need to do is the y, the x is equals to 2s exponential minus y over x plus y all over x. So let it be on y the x. So I don't need anything. I can now multiply through by s ds. If I multiply through by s ds, I'm going to have s dx in bracket the y dx. Sorry. Equals to 2s exponential minus y over x plus y divided by x multiplied by s dx. So this will cancel this. Then this will go with this. So at the end of the day, I have s the y equals to 2x exponential minus y over x plus y or the y or the x. So now that I know, yes, Charles?
Okay, so I was thinking maybe if we used the last method we used, since we already have our ds dy dx equal to that, just put the value of our y, which is vx, at the right hand side.
Yes, you are right. But remember, there are many ways of solving this problem. That's what I was telling you the other time. So you don't need to. So you might be thinking this is the best way for you. Other might be thinking it's not the best way for them. Do you get it now? So
Okay.
then you have to learn to accommodate others too. Is that okay by you? So it's still the same.
Yeah.
Okay, let's continue. So from this case now, we know that let y equals to vx. What is my dy? My dy is s dv plus v dx. Because I have the y here, I can also solve it this way. X in bracket s dv plus v dx, which is same thing as 2x exponential. Remember, this is negative. Y is vs over x plus vx dx. So in this case now, something is common to them in the other side. So I can also factorize what is common to them out. I know that I have x here, x dv plus v ds equals to s is common here. This one will cancel this. You have s is common. You have 2 exponential minus v plus v ds. So this goes with this. So what do you have? What do I have now? I'll have s dv plus v ds equals to, we can open the brackets by saying 2 exponential minus v ds plus v dx. VDS can go with VDS. VDS here, VDS here can go. So I'm left with x dv equals to 2 exponential minus v ds. So on this way now, we need to do the separable variable. Why we are doing separable variable, it simply means I can divide both sides by what? Anybody? I can divide s dv. You agree with me? I have x here, and I need v here to be 2 exponential minus v. So I will need 2 exponential minus v dv all over s into 2 exponential minus v. This cancel this. This also, this is s, sorry. This also goes with this. So in this case now, I have what? 1 all over 2 exponential minus v dv equals 1 over x dx. I can now integrate this side by saying, if I want to integrate this, I will have 1 over 2 inter, and I can say this is 1 all over exponential minus v dv, which is same thing as integral of 1 all over x dx. So exponential minus this particular 1 over 2, this particular one, I can rewrite it by say exponential v dv equals to integral of 1 all over x dx. So what do I have when you integrate this one? When you integrate integral of exponential 1 over, this is 1 over 2, this is still exponential v, which is same thing as ln x plus c. Recall that we have y equals to vx. So now what is my v? My v will be y over x. So substitute this 1 over x into where you see v. So it's going to be 1 over 2 exponential y over x is equals to ln x plus c. But in this case now, I think in this question, he has a boundary. Sorry, I didn't put the boundary here. So the boundary says, I have the boundary here, 1, 0. The boundary 1, 0, recall the boundary at this point is when S is 1, 0, you need to calculate this. It's just 1, 0, meaning when S is equals to 1, Y is equals to 0. So let's substitute it here. So we have it to be 1/2 exponential 0/1, which is the same thing as ln 1 plus C. So when you do it very well, although you can also eliminate this half, it's possible to eliminate the half so that, because let's first of all eliminate the half so that we won't put ourselves in the tight corner. When you multiply 2 by 2, you have it to be exponential y/x equals to 2 ln x plus c. But 2 ln x plus c here is the same thing as exponential y/2/x equals to ln s raised to power 2 plus c. So y is equals to 0, s is equals to 1. So it's going to be exponential 0/1 equals to ln 1. And ln 1 we all know is equals to 0. So we have 1 equals to 0 plus c, which implies that c is equals to 1. Then go back to the original equation. You can actually substitute your y equals to 0 there. So what's the value? How do we write it out? Anybody? Hello?
Hi.
Are we to substitute in the first equation, the original equation?
No. All they want you to get here is the constant c. What is your constant c? Constant c is equals to 1. So if my constant c is equals to 1, you know you can also work with this one from here. You agree with me? Do you agree with me that we can work with that?
Yes, yes.
Since if you know your c to be 1, all you need to do is just to say exponential y/x is equals to ln s squared plus 1. So what is y? How do we take y?
Y is 0.
We take ln of.
How?
Our exponential should cancel the ln.
Yes. Remember, that is why you can't go further here. You can't say you multiply this one by ln, you multiply this one by exponential. Is it possible? Hello?
All right.
Are you getting what
Ln is not possible.
Eh?
Ln is not possible.
Yes, that is why the question gave you the boundary, so that you can substitute the boundary just to get your c. That's what they want you to do. Are you getting the point now? All they want you to calculate here is calculate your c. That is why the boundary is there. Any question? Charles, you want to say something?
No, I'm okay. I'm okay now.
Do you understand what I'm saying now? Because if you said lin cancel this, what happened to lin? Nothing will happen. So we have to stop. So what you need to do is C equal, all they want you to do, when you see the boundary, please be careful. Immediately you see the boundary, they mean you should look for your constant. You yourself will know that it's only constant I can find here, which is your C. And once in that option, you just see 1, 2, 3, 4. You'll be like, why are they giving me 1, 2 instead of equation? So that is what they want you to do. Please take note of that. So you want to ask any other question? So there is one that is not that clear from your work, but I will quickly explain it before we call it a day. And I want you to also solve it on your own. It said the y, the x, is equals to 2y squared plus 3xy over s squared. Over s squared. Remember the way I explained the other time? Now you have the y, the s here, equals to 2y squared over s squared plus 3xy over s squared. We always look at the way whereby we will have y equals to vx or v equals to y over x. That's the way out here. So that's why you see 2 into y over x all squared plus 3 into y over x, because one s will have cancelled out here. And don't forget the y, the s. Charles, do you get this method now?
Yes, yes, yes.
That is your target should be this. What you want to use to substitute. If you can derive it from your equation, please, it's fine. Now, I know my dy dx. What is dy dx? My dy dx is what? S dv ds plus v. So you don't need anybody to tell you more. Once you have this at the corner, you can substitute. So I'll just say x dv ds plus v equals to 2. I have y over x. Y over x is what? Is equals to my v. Substitute it. Just put v squared plus 3v. Any question? I can take this one to the other side. I can say s dv ds is equals to 2v squared plus 3v minus v. Just to eliminate it. So I have s dv ds equals to 2v squared plus 3v plus 2v now, because you already deduct plus 2v.
2v.
So when I have 2v, what next do I need here? I can take 2v out. I can say s dv ds equals to 2v in brackets 1 plus v plus 1. I need to do the separable variable now in this case. How do I do the separable variable? You have to divide both sides by what?
By 2v into v plus 1.
Nope. So it's going to be s dv equals to 2v into v plus 1 ds. Are you getting it? Now, keep your 2. Just deal with the variable. Because there's no 2 here you want to cut. So I'm going to divide both sides by x first. Sorry. This one cancel this. I have the v equals to 2v into v plus 1 ds over s. So I need to eliminate v in bracket v plus 1. So I divide both sides by v plus in bracket v plus 1. So I'm going to have dv over v plus 1 equals to 2v into v plus 1 over s into v plus 1. I'm doing this elementary way so that all of us can benefit. So we can now integrate. Let's do it in a neater way. 1 all over v into v plus 1 dv equals 2 over s dx. Now integrate both sides. You can see. So when you integrate the both sides, you will have it. Now you will need what we call partial fraction to be able to integrate this side. And I want you guys to do that. I want you to solve this one and send it to me personally. This particular side using partial differential equation after the class. If you don't send it after the class, don't bother to send it again. Learn how to use partial fraction to solve this problem. So if you solve it very well, this particular, just tell me A equals to, you call this one A, you call this one B. So our A, if you solve it very well, you solve it in partial fraction, you have 1 all over V minus 1 all over V plus 1. Now dv equals to 2 integral of 1 all over x dx. So I can go ahead and solve this one after the other, using my integration skill by saying integral of 1 all over v dv minus integral of 1 all over v plus 1 dv. So if I solve it very well, I'm going to have 2 lim s plus c, and this one will be lim v minus lim v plus 1 equals to, this one we carry the negative, we carry the 2, we have lim s squared plus c. We know the law of indices says anytime you have a raised to power s divided by a raised to power y is the same thing as a raised to power s minus y. So I can divide this one, use the same law by saying ln v divided by ln v plus 1. So this cancels this, so equals to c raised to power s squared. Any question? Any question? Any question, please?
I think no questions, sir.
Silence means no question. So how do we replace? Here we have v into v plus 1 equals to c into s squared. you know your v is equal to y over s. Substitute your v into the place in order to get our y. The remaining is just algebra. That is y over x over y over s plus 1 is equals to what? If you solve this one, this particular one very well, you will have y over y plus x. So, which means I have y over y plus x equals to c s squared. So, I need my y. So I can cross multiply to any point in order to gain my y. Or take it to, or multiply through. If you multiply through by s, or how do you think we should do it? Anybody?
I think it's okay like this, depending on the way they answer. If this is to be an objective question, that will help us know what they're going to do.
Ibrahim, he said it's okay like this. Definitely,
it all depends on it all depends on if we're doing a pen of e-exam. That means the way they will state the answer will come in.
Yes, that you are right. You're absolutely right. That's one of the things some of us will need to do. I love your idea. Look at it before you can answer it. That okay, look at the way they structure the answer so that you will not overwork yourself. The examiner might not want you to solve everything. He might just want you to leave your answer this way. Fine. The examiner can want you to leave it more than this. Fine. It depends the way they normally.
You're right, sir.
Yes.
You're right. I discovered that in the TMA.
Aha. So first of all, study the answer. Okay, this is the way they put the answer. So when you are solving it step by step, you might not even need more to solve more than 3 or 4 steps before you arrive at the answer. So don't say, oh, you have to solve everything. We are doing everything in class just for you to know that you can. We are not preparing you, not only exam, we are preparing you life after the exam. That is what we are doing in class, which I want you guys to also emulate and look into that very well. So if you cross multiply, you open the brackets, then you can just, all you need to do is just to make y subject of formula. That is what we are saying. So we are, I think, let me stop sharing.